Hi everybody, this is Becky from the Sea Science Center in honor of Earth Week, not just Earth Day, but it should be Earth Day every day, but for Earth Week we're going to do some activities that talk about helping the planet out. So this one is about the water cycle. So you have some very simple materials. We're going to have some hot water, some cold water, some ice, and a pollutant. And you can use food coloring, you could use salt, you can use syrup, sand, or some cooking oil. So first we're going to fill up our bottom cup with some very hot from the tap water. And then we're going to take a second cup that actually fits into the first cup. And we're going to put some really cold water in that with some ice. And a little bit of our pollutant. And I'm going to use this grapeseed oil, cooking oil, as my pollutant today. Just a little bit, you don't want to add too much. And the key to this is having the cup fit in to the first cup without it actually touching. So it's just above. And what you're going to do is watch. So you want to take observations of this right away at about a 10-minute mark and about a 30-minute mark. So what's going to be happening here is kind of like the water cycle. So the sun heats up the water and causes it to turn into water vapor, and that rises up as a gas. But when it turns to water vapor, it doesn't take any of the pollutants with it. So anything that might be in the water that is being evaporated outside, whether it be waste of any kind, when it evaporates back into a gas and into the air, it is not going to carry the pollutants. The pollutants will stay behind. But then that water vapor turns back into water, back into a liquid. That's called condensation. So in this activity, what's going to happen is the hot water is going to heat up, and it's going to change the water to vapor, which is going to rise up towards the upper cup, and then it's going to start to condense on the outside, and the pollutant will be left behind. So the cooking oil, which is our pollutant today, is left behind. So we are actually recycling the water. So we are pulling some clean water away from the polluted water that is in the bottom cup. So we'll come back and check this in about 30 minutes to see what it looks like. It's been about 30 minutes since we started our experiment, and now we're going to remove that second cup from inside the first cup. So on the outside of this cup, it's hard to see, but I can certainly feel it, and you can see a little bit of the condensation there. So what has happened is that the water vapor floated up away from the hot water, and without taking any pollutants. All the pollutants are still in that cup. You can see that all the oil has been left behind, but the layer of water, the condensation on the second cup is all clear, completely crystal clear, pollutant free.
Hello, this is Adele at the Sea Science Center. In the activity Becky just showed you from her kitchen at home, you learned to recreate the water cycle to filter out clean drinking water from polluted water. This model of a machine on display at the Sea Science Center was created by Dean Kamen and his company of engineers, DECA, in partnership with Coca-Cola. It's called the Slingshot, and it's been deployed around the world to help people who don't have safe drinking water to be able to make some. It uses much the same principles as the activity you did in your kitchen. Let me show you. So this diagram shows how the Slingshot works, in much the same way as the cups you use in your kitchen. So you can see the dirty water comes in on the bottom here, and it gets heated up, and it moves to this chamber where it gets heated up even further. And then this area would be like the bottom of your upper cup, where the water would cool down and then condense. And then this area here around the outside would collect that pure water without any of the pollutants and bring it down here for safe drinking water. And the pollutants would be filtered out that side. So that's how this machine works, using the same principle you can do in your own house. So you can see science can be applied by engineers to solve problems for people throughout the world.